You might also be asked to find the correlation coefficient for these types of problem. So for the same problem that we talked about earlier, you might also be asked to find the correlation coefficient on top of finding the line of best fit and using that to predict the y variable. So before we find out how to find the correlation coefficient, we'll talk about it. We'll talk about it a little bit. So the correlation coefficient is usually denoted with R and is a number between -1 and 1. And basically, loosely speaking, it measures how well the data that you have, this data right here, for example, is fit by a line. So you might have a data that looks like this, for example, like this graph right here. The correlation coefficient R for this one might be 0.4, for example. You can think about this maybe, I don't know, the X variable being the amount of hours you spent studying, and Y being your GPA. R, the correlation coefficient 0.4, just means that there is a moderate relationship between the amount of hours one spent studying and their GPA. So basically, it measures the linear dependence, which is called correlation between two variables. For the second graph, you see how the data is all over the place. So if I was to make a line, this probably would be like this, for example. For this one, the correlation coefficient might be really, really low, like 0.01 or something like that, almost 0. So this means there is no correlation between whatever your X is and whatever your Y is. So if you take any two variables that are not related like that, then there is no linear correlation. And lastly, for this one, it could be that the correlation coefficient is also negative, so this might be -0.8 or something like that. So there's a negative relationship between one X variable and the other, the Y variable. So as X increases, the Y decreases. Okay. So let's see how to find the correlation coefficient. So we will use our calculator to find it. Again, if you are in stats, you might know how to find it by hand, but we're going to use our calculator. So we're going to turn on a command that gives us the correlation coefficient. So you're going to press second and 0, which takes you to catalog. And then you're going to go down until you find this command called diagnostic on. And then you're going to press enter twice to pick it and then activate it. Yep, we're still going. So there it is, diagnostic on, enter to select it, and then enter to activate it. So now you're going to go about doing a regular linear regression. So you're going to go to edit. We have the data also. We already have the data. Oh, we don't have the data. And so we're going to put the data in quickly. So it was 60, 70, 80, 90, and then started at 50, so 50, 60, 70, 80, 90, and then we'll have 169, 172, 174, 176, and 177. So now when you go to stat, calc, and do your linear regression, we can store the equation again, go to y vars, and pick y1, and then calculate. You're also going to see that the R is also displayed. So the correlation coefficient for this one is 0.9853. So R is 0.9853. So in MyMATLAB, this is what you would put in exactly with how many decimal places they're asking you to do it. So there is a positive correlation between the resting heart rate and the maximum heart rate. One more comment, if your calculator is not quite 84 plus, or if it's something like 83, you might have to do it a little different. So when you do stat calc and you pick linear regression, you might have to put list 1, which is here under 1, but it's blue, and then you put comma, list 2, and then comma, and then go to vars and pick y1, and then hit enter instead of doing it here if you have an 84 plus. So if you get stuck on that, just email me and I'll make a video or point you towards where to get that. All right, that's it.